my name's Darren Holmes, and today in Chapter 5 we're going to make a simple traffic light controller. So you can see we have our breadboard with our Raspberry Pi Pico microcontroller mounted on it, and we're going to put on 3 LEDs, a red, a yellow, and a green. Each LED needs its own current limiting resistor. So you can see we're going to use the 3 pins on the left hand side of the board. So we're going to be using pin number 20, 19. 18 has a special purpose, and that's ground. And we're going to be using pin number 17. So referring back to Appendix B in the pinout guide, so you can see our red LED connected to pin 20 is connected to GPIO 15. The yellow LED connected to pin 19 is general purpose IO pin 14. 18 is our ground, and 17 that goes to our green LED is GPIO 13. Now in the textbook they're using pin 38 for ground. So today, when I wire up my circuit, I'm going to use pin 18 just to prove to you that it does work. So when I wire my circuit, instead of using pin number 38, I'm going to be using pin number 18 for my ground. And I'm going to put my ground bus on this side so that I can hook my LEDs over to this ground bus. So I'm going to show you what that looks like now. So you can see I've wired up my circuit a little bit different from what the book shows us. I still have pin number 20 connected to a 330 ohm resistor. That 330 ohm resistor connects directly to my LED leg. Now my LED leg, that will be the long leg. The short leg goes directly into the ground bus. And the ground bus, you can see, connects over to my Pico in pin number 18. Pin 19 goes through the yellow wire to a second 330 ohm resistor. That second 330 ohm resistor connects to the long leg of the yellow LED. The short leg of the yellow LED goes into that ground bus. I just said that 18 connects my ground from the Pico to the ground bus. So pin 17 has a green wire in it, and that goes to the third 330 ohm resistor. The other side of the 330 ohm resistor goes to the long leg of the green LED. The short leg of the green LED goes to the ground bus. So up here on pin 38, you can see the ground from my last circuit, and you can see the power from my last circuit. I just left those 2 buses as they were. So the book shows you how to write the code. We're going to import the machine library. We're going to import U-time because we're going to have some delays between the lights running. And you can see they've named each of their LEDs by the color. So LED red is going to be going to general purpose IO pin 15. And it's an output. So hopefully you remember from the previous week, machine is the library, pin is the class. So amber is going to go to 14 and green is going to 13. Remember, these are your general purpose I/O, not your actual physical pins on the Raspberry Pi Pico. Now it's going to run in a continuous loop. So you can see we're going to start with the red LED, and we're going to give it a value of 1. So when I write my code, I'm actually going to give it .on. So a different method, just to show to you that different methods work the same as using value. There's a fair amount of code to type in. So it says in here the pattern will loop until you press the stop button. Also note that this light pattern is used in the real-world traffic control systems in the UK and Ireland, which means the light pattern is a little bit different from North American lights. So what you'll get in the UK and Ireland is the red light will be on, and then the red and the yellow come on. The yellow comes on to tell you the lights are going to change momentarily. Then the red and yellow turn off and the green light comes on. The green light stays on for a while, and then it switches to yellow and then red, just like in North America. So I've typed the code into Thonny, and you can see we have import machine, import utime, LED_red. You'll notice that this differs a little bit from the textbook. I've put an extra space in here so all my equal signs line up. That way when I look at my machine pins, I can see all my pin numbers in a complete column rather than trying to watch them poke in and out. Then down here in my while true loop, you'll notice I've used the method .on and .off. I think it looks a little neater than putting in the value number, and I like the word on and off to describe how my LEDs are going to operate. So I'm going to go ahead and run this and show you what it looks like on my trainer board. So you can see it starts with the red LED on. Then the yellow LED comes on to tell you it's going to change, and then it changes to green. Then from green it changes to yellow. And from yellow it changes to red. And then back to yellow, and then green. I'm going to stop the code right there. So this could be a safety issue. You'll notice when I stop the code, the yellow LED is still active. So the output from the Raspberry Pi remains active even though we've stopped the code from running. Now I'm going to restart running the code. So I'm going to click on Run Current Script. Notice the red and the yellow are on. And it stays on for a significant amount of time before the green comes on. So it didn't start with the red all by itself when I restarted the program. So when I press the stop button, it stops the code from running on the Raspberry Pi Pico, but it doesn't deactivate the output pins. So this could be a safety hazard if you're running some motors or anything that keeps running after you've stopped the Pico that could harm you. The second thing is when you run a program, so when I run this program in particular, you can see the first thing it does when it gets into the main loop is turn on the red LED. It does nothing about the state of the amber or green LEDs. So before you get into a while loop or main procedure in your program, you should always set your outputs to a known state. So for safety reasons, in here, I'm going to add 3 lines of code. So the 3 lines of code that I've added for safety's sake is to turn the red LED on, turn the amber LED off, and turn the green LED off. So when you're thinking traffic lights and there's a power failure, all the lights will be off. But when the power comes back on and it's restored to the traffic lights, the first thing that should happen is the traffic light should be red to stop all the traffic. You don't want it coming on in green or amber. So this code pre-initializes your outputs on the Pico for safety's sake. So we're going to start with the red LED on, the amber LED off, and the green LED off. It's good programming practice. So I'm going to show you what this looks like on the Pico. So once again, I've stopped the program where the amber or yellow LED is illuminated. So now I'm going to restart my program. You'll notice immediately the red LED comes on and the yellow went off. Now it seems to be going through my programmed sequence that I had requested. So this is a safety issue, and these are things that we need to think about when we're programming an embedded controller. So the next thing I want you to think about is when you come back in a year's time, or maybe 5 years' time, and you look at this code again, you're going to say, why did I set up those outputs right there? So it'd be nice to put in a little comment there to say why you did that. So under the reference documentation that we downloaded earlier, in section 2.1.3, it talks about comments. It says a comment starts with a hash character. Most importantly here, it says comments are ignored by the syntax. So that means it's not part of the programming code. So if we look at the tutorial, you can see it gives us some examples. This first line here says, has a hash. This is the first comment. We have spam equals 1, which means we're assigning 1 to a variable name. And here we have the hash symbol, and it says, and this is the second comment. And then below it, and now a third. So we don't even have to have a command on the line. All we have to do is have that little hash symbol. Now, most importantly, if it's contained in quotes, it's no longer a comment. So this is not a comment, it's data, string data that is being assigned to the text variable. So to leave myself a comment, I'm going to put in a blank line. I'm going to put in the hash symbol. And then I'm going to type my comment. So you can see I've typed in a comment. The entire line is in gray. So I'm going to click somewhere else. You can see it remains gray. It's actually not going to be code that gets used. It's just a comment for me when I come back later. So while looking at my while loop, you can see I've added 3 comments to 3 lines. So when the red LED comes on, it sleeps for about 5 seconds. So the red LED stays on for 5 seconds. Then the amber light comes on to tell you that the light's going to change from red to green momentarily. Now this is used for the UK and Ireland. They're going to take 2 seconds for this. Then we're going to turn off the red LED and turn off the amber LED. So the amber LED is really only used for the UK and Ireland. It's not used in North America. So I've put a comment on those 3 lines to indicate that's where it's used. Now, a lot of time in programming, what a programmer will do is if they don't want to use the code for this particular run of the program, right at the beginning of the code, they can put in the hash symbol, and that will comment out the whole line. So you can see that putting the hash symbol at the beginning of the line comments out the entire line. So I'm going to show you what this looks like on my LEDs. So in the next section of our book, it says real traffic lights aren't just there for road vehicles. So they're also there to protect pedestrians. So it's to give them an opportunity to cross a busy road safely. So in the UK, the most common type of these lights are known as pedestrian operated, user-friendly, intelligent crossings, or Puffin crossings. So I haven't heard of this before, but I have noticed driving around the city that if you're stopped at a traffic light, you can hear it beeping, and that's for the visually impaired. So what we're going to do is we're going to turn our little traffic lights into a Puffin crossing. So in the book here it says we're going to need a push button switch. So that's this guy right here, and that's going to go to general purpose I/O pin 16, and we're going to need a buzzer. So our buzzer is something we haven't hooked up before, so we do have a ground going to our buzzer, and the power for our buzzer, it looks like it's coming from general purpose I/O 12. So you can see on the pinouts in the appendix of our book, GP16 is on pin 21 and GP12 is on pin 16. So I'll show you what that looks like on my trainer. So you notice this is pin 1, this is pin 20, this is pin 21. So pin 21 is connecting through the blue line to my switch. The other side of the switch is connected to power through the power bus back to my Pico board. On the other side, you'll notice I've put in a small buzzer, and rather than wiring it up down the end of the trainer, I just used the wires that came with the buzzer. So you notice the red wire of the buzzer goes to pin 16. This is pin 1, this is pin 20, this is pin 16. And the black wire goes to the ground bus that I've used on this side of my breadboard. All my LEDs and resistors are as they were before in the previous example. So typically what we have right now is a sequence for the LEDs to simulate a traffic light. So it's going to go green, yellow, red, and continue. What we want is somebody to be able to come up to the crossing and press the button. Now if we're already at green, it's just going to continue on and go to yellow, and then go to red, and then it's going to check to see if the button was pressed. So if the button was pressed, we're now going to sound the buzzer. So we're going to make the buzzer toggle on and off so that it beeps, and we're going to extend the red so that the person can walk across the street safely. Once they've walked across the street and the buzzer's stopped, we can then continue on with our normal red and then do our green, yellow, red sequence over again. So our Pico has a dual-core processor. So we can use one processor to run the lights normally and another processor to monitor the switch. Now we have to be able to transfer data from one processor to the other. So when we press this switch, we have to be able to tell the code in the other processor that, hey, somebody pressed the switch, we need to do something about it. So in order to help me understand what's going on with the code, I've written an algorithm for the Puffin crossing light system. So going to Google, we can type in algorithm for computer programming, and it basically says a programming algorithm is a procedure or formula used for solving a problem. So an algorithm works by following a procedure made up of inputs. And algorithms are written in something called pseudocode. So to find out more about pseudocode, you can go to Google and type in pseudocode in computer programming. And you can see it's an informal way of programming description that does not require any strict programming language syntax or underlying technology considerations. It is used for creating an outline or rough draft of a program. So pseudocode summarizes a program's flow, but excludes underlying details. So all pseudocode is a set of instructions to myself of things I have to do. So it lays out the logic of a program for me. So a lot of times I'll get students who'll ask me to help them with their code, and the first thing I'm going to ask them for is their algorithm so that I can understand the logic behind how they've put the code down. And a lot of students will tell me, well, I'll write the algorithm when I got the code working. Well, you can't figure out the logic of the code if you don't have an algorithm. So looking at this algorithm, you can see the first thing I'm going to do is load the libraries. So we know from past experience with Python that we need to import the machine library, import utime, and in this particular program we're going to import underscore thread. So those are the libraries that I need to import. I don't need to define each of them here. I just need to, for logic's sake, say I'm going to load my libraries. So the next thing I need to do is define my pins. So in there, right, I'm going to have the red, the amber, and the green LEDs, the button, and the buzzer. So I know I've got to put those in there. Now, because I'm going to be using threads, I've got a dual core processor, so the program that's running on one processor needs to talk to the other processor. So one processor is just going to be monitoring the switch. So when somebody presses that push button, I need to be able to say that's true. So I'm just going to set a global variable to false to start with. So the next thing I need to do is define a function that's going to run in that other thread. So all I'm going to do is say define button thread. And basically in here, all that procedure is going to do is set a global variable to true if the button is pressed. So you can see, even though I've put it in 2 lines here, that's going to generate multiple lines of code when I come time to write it. So this helps me simplify the logic. So I'm going to load the libraries, define the pins, set the global variable to false, and then I'm going to create a thread called button, and when somebody presses a button, I'm going to set the global variable to true. So the next thing I need to do, and this is very important, is I have to start the button procedure in a new thread. Because if I forget to do this, it's not going to be running. You can press that button all day and nothing will happen if I haven't started the procedure in a new thread. So then coming down into our main loop. So this is our main program. So all of this stuff is just going to come into our main loop and just continue over and over again. So the first thing I'm going to do is check to see if that button was pressed. Remember, that was a global variable, so I'm just going to check to see if it was pressed. If it was pressed, I'm going to turn on the red LED. I'm going to beep a few times, and I'm going to set the global variable to false to say that the person has crossed the street. So when I'm done that, I'm going to go into my standard traffic lights. So the red LED is going to be on for 5 seconds and then turned off. Then my green LED is going to be on for 5 seconds and then turned off. And then my amber LED is going to be on for 1 second and then turned off. So what I like to do in here is I like to put a line down. And all that does for me is indicate that that isn't a loop and it's just going to repeat itself over and over again. So you can see an algorithm doesn't need to be very complex. The words that you use for your pseudocode are just whatever makes sense to you so that you can follow the logic of your program. So I highly recommend whenever you write your own code that you do write an algorithm to go with it, just so that you can better understand the logic behind your code so you know what the steps are. And if you ask somebody to help you, they have an idea of what the logic is behind your code, so when they go in and look at your code, they can see what those steps are. And it doesn't hurt to add a few comments into your code just to say that these are the things that you're doing. So the new lines of code that we need to add to our program is one line to define the button as being machine pin 16, and it's an input, and we're going to be using pull down resistors on it as we did in our previous chapter. The new one is the buzzer, and we're going to be hooking that up to machine pin 12, and it's just going to be an output. The next command we've got to look at is importing another library, and this library that we're going to import is _thread. So what this library does is allow us to access that second core. Now I've kind of mentioned variables before, so we're going to have a variable called button pressed. Our processor that's monitoring the switch is going to send some data into this variable. Now this variable needs to be used by both processors, so we call it a global variable. So by putting the word global in front of our variable name, that means it can be accessed in both processors. I think this is the first time we've said it's equal to false. We could have said it's equal to 0 or 1 or any other value, but we can also use true and false. The next section of code that we're going to be using is the code for our thread where it's going to be checking the button. So you can see in here we have to define it. So we're basically defining a function here, and we're just going to call it button reader thread. You can call it anything you like. The first thing we're going to do is say global button pressed. So button pressed is the variable, and we want to store data into it that we can send back and forth between the two cores. So basically, while true, an endless loop, we're going to say if button value equals 1. So if the button is being pressed, into the global variable button pressed, we're going to store true. Now we're going to put a little sleep in here, just so that this thing isn't running 100 miles an hour, so it gives it a little bit of a delay. So this routine just keeps running and running, and when the button's pressed, the variable is going to be assigned the value true. Now to start that new thread, we have to use this instruction. It's _thread.start_new_thread. And the name of the thread is button reader thread. And it expects us to send some information, so we're going to send it no information. So looking at this button reader thread, that has to be the same name that we defined up here. So to find more information, I went to MicroPython-docs that I downloaded earlier, and section 1.1.24 has the _thread, and it talks about multi-thread reading support, and it refers us back to the original CPython documentation. So that was all those files that we downloaded in a giant zip folder. So one of those files that we downloaded was library.pdf, and you can see in section 17.10 we have the _thread and its low-level threading API. So you can see in here we have the _thread.start_new_thread, and there's the function name and the arguments that it expects to see, and we just put in brackets and did not send it any arguments. So if you're looking for more information, this is where you find it. So lastly, in our while true loop for our main core, we're going to put in this code here that says if button pressed is equal to true. So the other thread or the other core sent us the value true. So what we're going to do is we're going to put the red LED on. So they're using value 1. I like dot on. So we have seen the for statement before. So we're going to use a for I in the range of 10. So it's going to count from 0 to 9. And what it's going to do is turn the buzzer on, sleep for 0.2 seconds, turn the buzzer off, sleep for 0.2 seconds, and then go back and do the next value. So it's going to do this 10 times total. And then we have to say global button pressed. And we're going to assign the button pressed variable false. Because now we've cleared it. We've done what it was supposed to do. We've given the person time to walk across the road. So you can see they give us the full code at the bottom of page 64. The import machine, import utime, import underscore thread. Then they're defining the LED, the red LED, the LED, the amber LED, telling you what pin it's going to be using. The green LED, the button, the buzzer. It initializes the button pressed value. So button pressed equals false, and it's a global button pressed. The next thing they're going to do is define that thread or that procedure that we're going to be running on the thread. Right here what they're doing is they're starting the thread. So we have to tell the processor that this is our function. So there's the function name, and we're going to start it in a new thread. Then you can see our main loop here. If the button pressed is true, we're going to do that beeping. So when we're done with that, the global button pressed is going to be set to false. Then we're going to go through our lights as before. So I've typed the code into Thonny. I've called the program Puffin underscore traffic underscore lights.py. So you can see I just copied it straight from the textbook. Global button pressed equals false. Sometimes I like to add extra lines in here to give it some white space so that I know what I'm doing. So here I'm defining button reader thread. Here's where I start the new thread. Now you'll remember I showed you how to use a comment. So here I'm initializing the pin outputs for safety. So I'm going to start with the red LED on, the amber and green LEDs off. This is my while true loop. So the first part, I've put a comment in here to tell me that this is the Puffin traffic light sequence. So if button pressed equals true, we're going to turn on the LED red. And here I've used the dot on method. I like to say buzzer on, and here I like to say buzzer off. Now I've put in another comment here. This is the normal traffic light sequence. You notice I've commented out the lines that were used for the UK and Ireland. So I'm only going to get the North American sequence of traffic lights. But if I want to come back later and actually activate any of the UK and Ireland lights, all I need to do is highlight that little hashtag and delete it. And that brings my code back up so I can use it again. So I'm going to run this code and show you what it looks like on my breadboard. So this is the normal traffic light sequence. It goes green, yellow, red, and then back to green. Now if I press the button, nothing happens. Now when it gets to the red, the buzzer goes and the red light stays lit longer. And then it goes back to the regular sequence. So this concludes Chapter 5 on traffic lights and using threads to use the second core in our Pico. In Chapter 6, we're going to create a reaction game. And basically what we're going to be working with is interrupts. So we're actually, when we press the button, we want to interrupt the main code and do something else. So we're going to be creating interrupt service routines. So it should be an exciting chapter. So please don't forget to subscribe, and we'll see you on the next video.